This is the companion video for problem solving with abstractions, parts 1, 2 and 3. In this video, I'll skip all the explanations and only show the code that I produced during those episodes, as well as some additional cleanup and fixes that I mentioned at the very end of part 3. If you only want to see that additional stuff, you can skip right ahead to timestamp 29 minutes and 52 seconds. The chapter is called Additional Work. And if you want to follow along and do the changes yourself, you can check out the code on GitHub. The address is github.com/programming2.0/asteroids. Link is in the description. I've organized the code into several different branches. 01 Abstraction is the one I begin with. If you want to follow along from the start, that is the one you should check out. 02 Problem Solving is where I ended the work in the main video, and if you only want to follow along for the additional work, check out that one. And finally, 03 Single Level of Abstraction is the work that I do in this video. You can check that one out if you want to see the end result. And as always, if you aren't sure how to use GitHub, you can simply click the big green button, download a zip file, and unpack that to your own machine before opening in your favorite editor. Anyways, let's get to it and start at the surface, unless you decide to skip to 29 minutes and 52 seconds. I began by taking a detailed look at the task, the problem that I have to solve, and broke it down into smaller parts. Not looking at the code at all, but staying at the same level of abstraction as the user. And with having a better understanding of the problem, I'm now ready to dive into programming and write some code just below the surface. First, when a user presses a key, the spaceship should fire a shot. So in here, we add a check. If key equals. We forgot to agree on which key to use for firing shots, but I'll just use space. And if that is pressed, we call the function fire shot. But we are in our constructivist mind, so we write code as we wish it would be on the highest level of abstraction, and then we expect someone else to construct the lower level details afterwards, even when that someone else will be our own future selves. We can help them a tiny bit though and create the function, but don't actually implement any functionality. We'll create the function fire shot and just let it output something like not implemented. So the program will still run, although not work as expected. That was the first part of the task. The next part is moving the shot. So let's move further down the code. All the way down here, where we move the spaceship and the asteroids, we also add a call to move shots. Like fire shot, that is a function that doesn't exist yet, so we'll just declare one way up here, together with the other one, fire shot, function move shots, and just like the other one, that'll say not implemented. Then we have to check if any of the shots collide with any of the asteroids. But now we've hit a bit of a snag. There isn't a function to check collisions, only this loop that checks every asteroid and asks if it is colliding with the spaceship. And since that is a lot more detailed than a simple function call, it must also be on a lower level of abstraction, a level we don't yet know how to implement. So we can't really get any further. In the main video, I then spent some time going above the surface, abstracting even further to understand that shots are a lot like asteroids, only turned upside down. So I should be able to implement shots by copying the code for asteroids, noting that FireShot would be the same as CreateShot, which could then be copied from Create Asteroids. We notice on this high level of abstraction that it is called Create Asteroids with an S, meaning that it creates more than one asteroid. That is not what we want for shots. We only want to create a single shot. So before copying the entire function, we dive into it. There's this loop that repeats 10 times. So without even looking at the code inside the loop, I'm just going to assume that it creates a single asteroid. I'll just pretend that I can't see this as anything else but a big blob, and that is what we copy to FireShot. If we run the code as it is now, meaning if we swim up to the surface and take a look at the game, we can see that when I fire a shot, it just creates more asteroids, which is to be expected. So that's actually a good thing. So we can swim down again and deeper inside the function. We don't need to understand all the details, just enough to change it from asteroids to shots. For instance, here it says asteroid, so let's just change that to shot. And down here, it pushes an object to a list of asteroids. Okay, so we need a list of shots instead. So let's just copy the entire list of asteroids to up here and make a list of shots. And then remember to push to that list. And this obj here, that must be a shot. So let's just rename it to shot. Let's check if that was enough. Well, there's a new shot appearing up here in the corner. It should really appear at the position of the spaceship. But we haven't written anything to say that, so let's dive back into the function, take a closer look at this shot object. It has a bunch of single letter properties, x, y, w, h, and s. X and y are probably the x and y coordinates. And since the shot should appear at the position of the spaceship, let's just try to put spaceship.x and spaceship.y to see if that does any change. No, nothing. It feels like it should work. But the fact that there was no change at all makes me think the problem isn't here. So we leave the function, swim out of it, and towards the next one, move shots. This time, both function names are plural, shots and asteroids, so I'll just blindly copy the entirety of move asteroids into move shots, and then change every asteroid to shot. There is this for loop that goes through the list of asteroids, and it should go through the list of shots instead, and every object would then be a shot and not an asteroid. But be careful with the automatic renaming when doing this kind of copy-paste coding, because when we have a reference to the list of asteroids, we don't want to rename it to shots, because that would rename the actual list. Instead, we want to replace it. So we just type the new name here. But then this asteroid here, that's a local variable. That doesn't reference anything outside. So that one we can rename to shot. Cool. Now we'll dive a bit deeper into the loop and see what it actually does. Let's just zoom in. First, it adds something to the y-coordinate of each shot. Adding means moving down, and we want to move up, so we just change this plus to a minus. Then it checks if this y-coordinate is greater than some value. Why does it do that? And what happens if it is? Let's dive a bit deeper and learn what happens inside the if statement. It sets these two properties here, y to minus 30 and x to something random. What's the deal with that? And where have I seen that before? So, wait a second. It was in Create Asteroids. It did the same. It sets x to something random and y to -30. So these are the initial values of a new asteroid. So kind of this restarts the asteroid from the top once it has reached the bottom. That really could have been abstracted into a function called restart asteroid. But is that actually what we want? That is what we forgot in the plan. What should happen to the shots when they leave the screen? I don't think it makes sense that they restart. They should really just disappear, be removed so that they no longer exist. And since the shots don't reach the bottom of the screen but the top, I'll change this if to check if y is less than 0. And if it is, we don't call restart asteroid, but remove shot with that shot. That function doesn't exist yet, and we don't know how to implement it, so we'll just create another one of these not implemented functions. Remove shot with the shot, and just console on not implemented. At some point, we do need to swim deeper into that function, but first let's go to the surface and check out the result. Still doesn't work, but the shot is there, and if I inspect it, I can see that there's a lot of shots, and the not implemented function gets called all the time, and I can watch this, my list of shots here. Let's just say the first one, and it changes the y coordinate. So the code does work at the lowest level of abstraction. It changes the values as it should, and it calls the remove function. It's just that nothing happens on the screen. That was quite disappointing, and I then spent a very big part of the main video, the entirety of part 2 actually, exploring different levels of abstraction. And I learned about single level of abstraction, the idea that everything inside a function should be on the same level of abstraction. So I decided to clean this code up a bit and hopefully find a fix to the problem that way. First of all, it doesn't really help that our abstract functions from last time are right here in the middle of the function. The whole idea of abstraction is that we don't have to look at all the details all the time. So let's move them out of the function, out of sight. Down here they go. Now we can see the entire function, and it is a bit of a mess, so let's begin cleaning it up. First, the delta calculation. It is something technical, very close to the platform and not really part of the problem domain that the user understands. So it'll never fit in with the rest of the abstractions. And you could argue that we should leave it as is, as something that doesn't belong. So it has to be on a different level of abstraction. But we don't really want or even need to draw attention to it. So we'll treat it the same as every time else and abstract all of it into a function. Most editors have built-in tools for doing these kind of changes where we move code around without changing what it does. It is called refactoring, and the specific operation we want to perform is extract to function. And the reason it's called extract and not abstract is that we could use it to simply move code around without making it more abstract. We just take it out of one function and put it into another. But let's extract this, and it's done, but it shouldn't be called new function. We use it to calculate delta, so that's what it should be called, calculate delta. Our move functions here, they can be left as they are, but this for loop. Last time I didn't want to put it into a function, but it really should, so let's abstract that as well. And it checks collisions between the asteroids and the spaceship. So in a sense, it ought to be called that. Check collisions between asteroids, and spaceship. But that's a bit of a mouthful, so let's settle for check collisions. Then there is this visual spaceship thingy here. It does something with the visual spaceship, translates it to the x and y of the spaceship coordinates. I think it displays the spaceship at the correct position. So let's extract all of that to a function called display spaceship. And this loop, it does something similar, but for the asteroids. We could either create a function for the inner code, this part here, and call it display asteroid, but we already have a move asteroids function. So let's just take the entire loop and extract it to display asteroids. And then these two lines here at the bottom, well, they also seem to display something. This one displays the score or the points. Wonder what the difference is, but let's just rename it, extract to a function, and let's call that display score. And the last one, that displays the health. It looks much nicer now, very clean, very calm with the single level of abstraction. And it helps us notice that we call move spaceship, move asteroids, and move shots, but only display spaceship and display asteroids, but no display shots. So let's create that. First, we make sure that we actually call it, even though it doesn't exist yet, display shots. And then we go to display asteroids and copy it in its entirety, put it up here, and remember to rename it to shots and loop through the list of shots, and everything inside it is a shot. Notice how we still have more than one level inside the function. First is the loop that goes through our list of shots. That's a fairly high level. Then for each of those objects, we do something to the visual shot. That's part of the platform and thus a very low level. But in that low level, we mix some of the higher level properties of the shot together with some code we might not understand. So we have this foreground background thing going on. We can choose to ignore the platform dependent code and focus on our shots, or we can ignore the shot and only focus on the platform code. For now, we can probably ignore all of it, so let's swim up again all the way to the surface and check if it works. It does go a bit slow and sometimes seem to fire more than one shot, and they shouldn't really be on top of the spaceship, and they're also a bit too far to one side, but that's details. We can fix those later. Let's just celebrate that it works and continue implementing the missing features, meaning that we have to dive deeper into this function here, remove shot. There isn't anything to copy, but we realized that removing a shot is exactly the opposite of creating a shot, or as we called it, a fire shot. So maybe we can turn that code upside down. Let's see. First, it creates a div. That is something very close to the platform. And then it adds a class to that div, and it inserts it somewhere in the document, meaning displaying on the screen. After that, it creates a shot object with all of these properties here, where we at least understood X and Y, and visual turns out to be the link to the div. Okay, and then that object is pushed to the list of shots. Okay, I clearly see two different things going on here at two different levels of abstraction, the platform and our shot object. So in order to make this entire function a single level of abstraction, we need to extract the code into two separate functions. These three lines, they create the visual part of the shot and adds it to the screen. So let's extract them into a function called add shot to screen, for lack of a better name. And then the rest, they create the data object and add it to the list. So extract that to add shot to list. And it even receives the div we just created, so it can be stored as visual. Cool. Now the fireshot function is very clearly telling us that it does two things. It adds a visual shot to the screen, and it adds a shot object to the list of shots. And if we just hide those two functions, that means that remove shot should do the opposite. First call a remove shot from screen and a remove shot from list. So let's code that. Get rid of the not implemented and instead call the two still non-existing functions. Remove shot from screen, receive the shot, and remove shot from list. And both of them should receive the shot so they know which shot is to be removed. Then we create these two functions and make them say not implemented. Function remove shot from list from screen, like this. Now you might immediately argue that we aren't any closer to solving the problem. In fact, we now have two not implemented functions, so you could think that we are now twice as far from a solution. But we have moved to a lower level of abstraction, and since there's always more details on the lower levels, after all, abstracting is about removing or ignoring less important details, it makes sense that there are more details to implement. So I wouldn't worry at all, just dive into these functions one at a time. Remove shot from screen should be the opposite of add shot to screen. And as we discovered earlier, that created a div element and added it to the screen. So we need to remove a div element from the screen. That sounds very close to the platform, which is great because that means that if we don't know how to do it, someone else does, and we can simply search for the answer. So just say remove div, and turns out there is a remove method that we can use if we have the element, and we do. That was stored as the visual property in our shot object. So remove shot from screen should simply be shot.visual.remove. Nice and simple. Now for the remove shot from list, that is the opposite of add shot to list, that created an object and pushed it to a list. That is also an abstraction very close to the platform, the JavaScript programming language. So let's search for how we remove something from a list. JavaScript remove item from list. And I'll skip the AI answer and go straight for Stack Overflow. And here it says, find the index of the array element you want to remove using index of, and then remove that index with splice. Okay, and here's an example. We have an array, and then we find the index of the element called 5, and for us that would be shot. And then there's an if statement for safety, but we ignore that. And then we just splice the array with the index and the number 1. Okay, so let's try that. remove shot from list. We find the index is the shots index of shot, and then we splice shots with that index and the number 1. Cool, let's try it. I fire some shots, and when they reach the top, they disappear, I think. Let's see. They are no longer on the screen, and they are no longer in the list. Very, very cool. Now, we only need one last thing, the entire reason for everything we've done so far, checking if those shots collide with the asteroids. So far we spent most of our time on the first 2 parts of the task and a considerable amount of time cleaning up the code and understanding the different abstractions. And far too often when taking on a large task, we underestimate how long it will actually take. There is a joke that says that the first 90% of the work takes 90% of the time, and the remaining 10% of the work takes another 90% of the time. But there's also the idea that doing preparatory work, like covering up everything before painting a room, actually saves time. So I hope that also goes for implementing this final feature. It's going to be inside our check collisions function, so let's dive into that. That loops through all the asteroids, and for each one, check if it is colliding with the spaceship. That's fine as it is, so let's keep that and add some more. In addition to checking for collisions with the spaceship, we also want to check for a collision with a shot. So if is colliding the asteroid with a shot, but there's more than one shot, so we need to loop through the list of shots, and for each one check if that one collides. So we write for const shot of shots and move the if statement inside the for loop, and if they are colliding, then what? Oh yeah, that's right, we should remove both of them. The shot, since it has been spent, and we should also remove the asteroid because it dies. Remove shot we already have from before, but remove asteroid does not exist yet. But remember how we copied everything else from asteroid to shot? Surely we can do the same again, just the other way around. So let's copy remove shot and all of its related functions down here to remove asteroid. So now just change shot to asteroid, and when you have to edit a lot of different places at the same time, like this shot and this shot and this shot, the easy thing is to use multiple cursors. You simply click the first one and then hold down Alt or Option or whatever the key is for your editor, and click the next one and the next and the next and the next, and then you mark the shot and write asteroid like this. And for the inside of the functions, this shot is now an asteroid, and the same as this, and the same as this. And I just need to remember to also change shots and not rename it this time, but just change it from shots to asteroid. And this one. So now we have remove asteroid from screen, remove asteroid from list. Let's try it out. And it works. And that is where the main video ended in regards to changes to the code. I talked about that the rest of it, the parts not visited yet, could also benefit from being refactored into single levels of abstraction. And there's a lot of small details, like the shots are a bit too slow, too far on one side of the spaceship, on top of the spaceship rather than below, and the collisions might need a bit of adjustment. In this video, I'm going to do all of that, beginning with creating a new branch to separate the work from the main video and this video. And I'll call it, say, 03 single level of abstraction. When I created Remove Asteroid, I knew that I first had to remove the asteroid from the screen and then remove the asteroid from the list. And I knew that because I copied Remove Asteroid from Remove Shot, where I also knew that first I had to remove shot from the screen and then remove the same shot from the list of shots. And I invented this function by inverting the create shot function, or fire shot as I call it, where I figured out that first I add the shot to the screen and then I add it to the list. So this is at a single level of abstraction. It talks about the abstract idea of a shot being added to a screen and then to a list. And then the actual implementation of those are here, where I create an object that I add to a list, and I create a div that I add to the screen. So this is a perfect example of single level of abstraction. But as far as I remember it, that's not how I did it in Create Asteroids. This has several levels of abstraction. There's this part that creates the div on the screen, and this part that creates the object in the list, and it's all wrapped in this part that creates a number of asteroids. So let me begin by creating a create asteroid function. Instead of create asteroids, I want to have a single function for creating a single asteroid. So let me extract this to a function called create asteroid. So now I create 10 asteroids. Very nice, very simple. And this one, I'm going to do the exact same thing that I did for create shot, fire shot, where I first add a shot to the screen. So refactor this and extract it into add not a shot but an asteroid. And that gives me a div. And then in this one, this part, I'm going to add it to the list. So refactor that and extract it to add asteroid to list. And if I look at the code side by side, now we can see create asteroid, fire shot, they almost match. First I add it to the screen and then I get a div that I add to a list. And inside adding to a list, I set X and Y to something and I push it to the list of asteroids. Maybe I should just name this an asteroid. And in add to screen, I create an element and give it a class and add it to the game field. And I do the exact same thing here. So that's a very nice abstraction in both cases. So let's see if there are more functions that need abstracting. How about move asteroids? I could extract this into a single function called move asteroid, but I'll leave it be. But then there's this piece of magic here. I talked about that's really for restarting the asteroid. And if I take a look at it side by side with adding an asteroid to the list, it's almost the same as goes on here. It's just swapped around. So maybe I should actually extract this into a function. And I talked about it earlier, and now I'm going to do it. Extract into restart asteroid. And then to avoid copying it over here, I'm just going to set X and Y to 0. And then just before pushing it to the list, I'm going to restart it. Not remove it, no. Restart this asteroid. Excellent. Let's see if there's more. Display asteroids. Nah, that's fine. And those are fine. I move the spaceship. I display the spaceship. And here I have display health and score and check collisions. And all these small helper functions here for calculating the delta and slowing down an asteroid, losing health on a spaceship, checking if an asteroid and spaceship is colliding, calculating the distance between two objects, and the combined size of two objects. Let's scroll the other direction and see if there's more code that should be on a single level of abstraction. That was as it was. And fire shots. No. Excellent. So that is all the single level of abstraction I need, and I can now collapse all of my functions here, just so I don't need to see them all the time. And suddenly it looks almost magical. I have the shots here, and where I fire shot, add shot to list, add shot to screen, move shots, remove shot from screen, remove shot from list, and display shots. And I have the same for asteroid. Create asteroids. I'm just going to collapse that one. And create a single asteroid, add it to the list, to the screen, move it, and restart it, display all the asteroids, and remove an asteroid from the screen as well as from the list. So except for the order, maybe I should just move display asteroids a bit further down here. So now they look almost identical. I can see that for every function I have a shot, I have a matching one. For asteroid, except this one, I have restart asteroid, I don't have a restart shot. So now we can truly see how they both abstract to kind of the same thing. That was single level of abstraction. Let's take a look at the running game and see if there are other small details we need to adjust. The first thing is the shots move very slowly, but they also move at different speeds. So let's see how that can be. I don't remember making anything about speeds, but when I create a shot here, I set this S value to something random, and S is probably speed because it's the only one that's random, so it's the only one that can be different for every shot. So I have a random number between 0 and 100 and at 50, so that means between 50 and 150. So if I just say always 150, let's see how that goes. Now they are all the same speed. Still a bit slow though. Let's crank it up to maybe 250. Oh yeah, this feels much better. Now it's more of an action-oriented game. So the next problem is that the shots appear on top of the spaceship. And let me just check. That is because when I fire a new shot, it is added to the game field after the spaceship. And in HTML, the rule is that if something is added after, then it is on top. And if it's added before, then it is below. So we just have to change that. Let's look into the code. Where we add it to the screen, we add it to the game field before the end. That means at the very end. But we just want to have it at the beginning. So after begin. And let's see what that does. Yes, perfectly. Now the shots are below the spaceship. They're still a bit too far to the left. I would like them to appear here in the middle. So that's the next thing. When we create a new shot, we use the X and Y coordinates of the spaceship. And I'm fairly sure that these reference the center of the spaceship. But just to be sure, let me take a look at the game. Here I have the spaceship. And if I ask the object spaceship, it has an X value of 380. And if I change that, spaceship.x, say 300, it moves to the left. And if I change this to a 0, that means that the center, I hope the center, whatever point on the spaceship I control, should go to the very edge. And it is the center. Excellent. So when I create a new shot, I can't actually see them here. That means the center of the shot should be the same as the center of the spaceship, but it isn't. The only other variables I have here are these W and H, and I don't know if it's because of them, but let me just try and change it to maybe half and see if that does anything. Nope, nothing at all. They are still to the left of the center. So this, when creating a shot, it doesn't have any influence at all on where they are displayed. So maybe it is the way they are displayed. Here I displayed at an X minus something. I don't know where that number comes from, but let me just try the same. Just half it and see what happens. That actually did it. Excellent. That worked. I'm not too thrilled about just changing some arbitrary number to a different value, especially since I don't know what it means in the first place. But it does seem to do the job. Changing it does work, so I'll guess I'll have to leave it as is and get on with the next thing. When I shoot the asteroids, the shots don't even have to touch it before it disappears. So there's some other numbers I have to change. And I'm guessing that since W and H didn't change anything with the position, the visual position, maybe they changed something with the collision detection. So let me try once again, change it just to half, see what happens. Oh yeah, that's much better. Still not perfect. Maybe I can make it even smaller. Half again. 12. See what happens. Oh yeah, now the shots actually hit the asteroid before it disappears. Again, just changing arbitrary numbers to different values is a bit hard to understand and does seem like something that should be abstracted a lot more. But I don't know how to do that yet, so that'll have to do for a later video. At least now, I have a fully functioning game where I can shoot down the asteroids before they damage the spaceship. And let me just end with a quick recap of all the work that has been done so far. It started in the 02 problem solving branch, where I can see the history, and it began with adding but not implementing fire shot and move shots. That was where I created the not implemented functions. And then I implemented fire shot and later move shots, and then I got stuck. Couldn't go any further before learning about single level of abstraction. So I abstracted the rest of the code in the tick function to separate functions and reorganized them a bit, moving things out of tick. And then I realized that I needed the display shots, so I added that. After creating display shots, I could now fire shots and they were moving up the screen, but I realized that I also had to remove them once they either hit an asteroid or left the screen. And since I didn't know how to remove them, I figured that it must be the opposite of creating them. And fire shot was the one that created shots, and by putting that on a single level of abstraction, I was able to turn it upside down and create the remove shot that was just doing the opposite. And I started at a high level of abstraction with that, with not implemented functions, and then I implemented those. And finally, as the very last thing, I implemented the collision check and remove asteroid. And that was all done in the main videos. And then in this companion video, I made every function a single level of abstraction, all the functions that I've left out of the main video. And I fixed the speed of the shots so it wasn't random, but a fixed value. And I moved them below the spaceship rather than on top by changing where they were added in the HTML. And I moved them a bit to the side so they weren't, actually it kind of is the opposite. They were a bit to the side and I moved them to the center. And I adjusted the shot collision at the very end. If you want to follow along and do the same work, you can either start from the beginning at branch 01 abstraction, where I started the first video in problem solving, or you can skip everything in the main video and check out branch 02 problem solving and begin what I did here what I only did here in the companion video, or you can look at 03 single level of abstraction and take a look at the finished product. It's all up to you. Anyways, I hope you enjoyed. I hope you get inspiration for doing your own projects, and I hope to see you next time. Bye for now.